Alright, so I'm going to play the video. You're going to watch the man walk. Alright, so watch the motion. That should give you an idea of how you should draw your 3 sketches. Okay? So I'm not going to answer any questions, so I bet you have a question that I'm waiting to see how your sketches look. Draw your 3 sketches. Write in your constants. Go as far as you think you can as I walk and look at your sketches. Alright, let's talk about your diagrams before you go further, because half of you have correct ones, half of you have info missing. It really depends upon kind of the information that's there. So, you always want to represent the whole picture. What creates the shadow? What makes the shadow happen? The lamppost, so you can't ignore it. Okay, so if all you do is have a 6 as your left side of the triangle, then you've ignored half the problem. Okay, so if that's the 6, change it to 15 and add in a line. Because I need the man that's 6 feet tall to still be in my picture. So that's 15, that's 6. I can use this bigger one, 15 and 6. You don't have to label every single one, but that's our way of being able to tell if there's constants. I can only put constants in that picture. Those are the 2. The lamppost doesn't change size. The man that was walking never changed size. So let's talk about the question, which we can see it. How fast is the shadow lengthening? So you want to label in your picture where the shadow is. Use the letter S. S for shadow. Label where you think just the shadow is. Okay, and then look at each other and double check that your answer looks the same of where you're placing your S. So I'm going to restate it a different way. The shadow, you're going to label your S from where the shadow started to where it ended. That's really important to hear. Where it started to where it ended. So you should have a little tiny S here, maybe a bigger S here, and a much bigger S here. How did I know that that's the shadow? That one's the easier one. That's actually the easier one. Here's the next question. Because once we do our question, now that I labeled that S, what's our actual question? DSDT is the question at an instant. Did they tell us when they wanted us to do it? No. Okay, you're not wrong. They just didn't give it to us. Given. We got the 6, we got the 15, 5 feet per second. Alright, first of all, it's feet per second. That makes it easy. D what on the bottom? T. Alright. So, this is what's confusing about the problem, is that's supposed to be the man walking. So I'm going to ask the question the same way I did for the shadow. Where did the man start to where did the man end? Let's use X for that. X. These are the same letters I used in my other class. X. So label in your picture where the man would have started walking to where the man ended walking. And if you need to see the man again, here he is. Okay. So, what does that tell us? Where did the man start? At the lamppost until himself, right? Listen to the way that I said that, though. It was based on where it started to where it ended. So then, this speed that's here, this velocity that's here, is dx. It's the distance he went divided by the time. He's not over here. It's only this little piece. Alright, so I'm going to use my bigger picture here. Given the constants are already there, so now we're at formula. Well, all 3 triangles are right triangles. Thumbs up if you think it's Pythagorean. Thumbs down if you don't think it's Pythagorean. That way I know you're not just falling asleep on me. Thumbs up if you think it's Pythagorean. Okay, that's one of our right triangle things. What else we have? SOHCAHTOA. Thumbs up if you think it's SOHCAHTOA. Alright, thumbs up if you think it's area. Base and height are given. I haven't hit it, huh? Base and height are given. That's a true statement. So which one are your thumbs up for? Area? Yes? Okay. Which one? Baldrick. Area. Okay. Man, I'm good at convincing people. Yeah, I'm good. Lottie, what about you? Pythagorean? Any other strong votes here? Pythagorean? Okay, so I'm going to start breaking down your votes. Gotta do it. Alright, area. Where in this problem are we talking about area? We're not talking about area. Don't introduce new things. They don't want you to introduce new things. You're just making your life all complicated. There's no area. Right? We're just talking about moving, distances. So that breaks down. Base and height were given, but it's not going to be helpful because now you're going to bring in A. We don't know anything about A. Pythagorean. Pythagorean would be A squared plus B squared plus C squared. I need this to have a label. Let's call it C. We're doing related rates. So when I take the derivative, because it's with respect to t, Lottie, what do I pick up because I have an x? Because I'm doing related rates with respect to t, when I take the derivative and I have an x, what am I going to pick up? A dx dt. And then Jake, what am I going to pick up here? And then Travis, what am I going to pick up here? Which would be okay, except for you just introduced another variable. You're trying your best not to introduce if you don't have to. Do we know anything about dc dt? Did they tell us? This is our question. We have this one. I don't have the other one. We can't use it. Does that make sense to everyone? Okay. So I've taken out all your arguments for those two. SOHCAHTOA. Let's kill that argument. I had one or two of you picking that one. Can someone raise their hand and give me the argument as to why SOHCAHTOA is probably not going to be used? Raise your hand for that so I can actually hear it clearly. Ty, what do you think? Because there's no angle. Remember, those are the things you're thinking about in your head. You have mini-me sitting on your head and whispering in your ear, telling you all these things. That's hopefully how you test, right? That in my mind is how you test. You have me sitting there whispering in your ear. All right. So I've taken all those and chopped all your arguments to pieces, and now we have no formula. Someone want to raise their hand and give me a formula? Baldrick. Okay, we are talking about distances. We usually use distance formula as x2 minus x1 squared plus y2 minus y1 squared. Never mind? Never mind. So distance formula, we usually use coordinate axes. That's kind of the hint why we're not. I actually did hear the answer somewhere. I can't remember. Actually, no, I do remember who it was. One person yelled it out at the beginning of the problem. No one feels confident enough to give a supposed relationship? No? Who? It's going to be my new favorite student in life if they can figure it out. I said that because Ty said it before and I didn't want him to be my favorite student, so I gave it to Julie. You yelled it out at the very beginning. It's a proportion. It's a proportion. This problem starts off really ugly because you have all these definitions and variables you have to label, but you're going to see how simple it becomes once we start the formula. So your formula, please be careful. When we talk about triangles, we don't talk about pieces of triangles. When we talk about similar triangles, it's all three sides are proportional. So I'm going to use my big picture here, and I'm going to draw the little one down here to separate them from the picture. And I want you to write your proportion, but remember what I just said. We don't talk about pieces of sides. We talk about all sides being proportional. So go ahead and write your proportion. There's many different ways you can do it. I'm going to give you literally 30 seconds to try and write it. When you try and compare with each other, they might be different, so you can talk through it if you'd like. All right, proportions you could write. You could do left side over the bottom of the larger triangle equals the left side over the bottom of the smaller triangle. Or you could do left side and left side, bottom over bottom. Those are two, they're pretty much the same. So if I asked you right now to take its derivative, is that going to be a pretty derivative? No. But we can do a nice little makeover. Let's simplify it, because when we simplify, we do a makeover. We don't change the problem, we just make it look different. What should we do? Cross multiply, get it out of fraction form. We don't want those fractions there. If we can do something easy to get rid of them, let's do it. So what do we have? 15s is equal to 6x plus 6s, please distribute. Do we want to make over any more? Are we good? Yes? Probably get the s's together is my guess. Are we done making over? Yeah, why not? You could divide by 3 if you'd like. That don't matter to me. So take the derivative of the left side. Matthew, what do I get for the derivative of the left side? Good. Don't forget that dt piece. And on the right side, Kevin, what do I get on the right side? dx over dt. Yep. Do I have everything I need? One thing that we noticed in the beginning, did they give us an instant? They didn't. Why not? Because you didn't need it. You actually didn't need it. Okay? So I believe ds dt ends up being how much? Give it to me as a fraction, please. So dx dt is 5, 30. Was it 30 over 9? 10 over 3? Let's give it some units. What are the s units measured in? Feet. What are the time units measured in? Second. All right? Don't forget your units, please. All right. Thumbs up if we're good up to here, because we're going to add in one little piece. Thumbs up, thumbs down, thumbs to the side. I need to know. All right. Lottie, are you ignoring my thumb request? All right. So we're good up to here. So now we got to do the next question. Now, one thing I want you to understand, as long as we're still talking about the same problem during the same instance, and in this case the instance doesn't matter because we didn't need it, then everything we know here is true. So here where it says how fast is the shadow tips moving, I didn't change the instant. It's the same time. Therefore, everything on this board is already true. Okay? Take your picture, and I want you to think about the shadow tip. Let's use the variable z for shadow tip. How do we figure out how to label the variable? We look at the shadow tip from where it started to where it ends. Label your figure. Shadow tip, where it starts to where it ends. And if you're confused, watch that red dot. That's the shadow tip. Where does it start? At the pole. Ends all the way at the end. So in our picture, we started exactly the same. So I said use z. Okay? Right? Started at the lamppost, ends all the way at the tip itself. There's your z. Thumbs up if you think you have a formula. Because everything else, we have the given, we have the question now, right? Let me do that here. What's the question? How fast is the shadow tip moving? The shadow tip is variable z. So, my question is, thumbs up if you think you have a formula. Then we'll go in a little deeper. Thumbs up if you think you have a formula. Formula takes 2 seconds if that helps at all. And since I got barely any people and Julie already spoke, let's go with right. What do you think? Pythagorean theorem. Where? That one? Do we know that one? No. So I would introduce a new variable. Do we want to introduce? So no. Okay? So we talk through that. Because you're going to have to do this. You're going to have to pick a formula and decide if it works or not. So you have to be able to talk through if it works or not. All right. Matthew and then Julie, if he doesn't get it, coming back to you. Oh, you guys are thinking so hard. Julie, you got something? No. I need a formula first. You already took a derivative. What's a formula? I feel like Isaac might have this. Yes, sir? X plus S equals how much? Come on, people. You see it? You see our picture? Do you see the picture? Do you remember geometry? Like, I don't know, some of you 6th, 7th, 8th grade year. I don't even know when you take it. And they had like segment addition postulate. One little piece, but the other little piece makes the big piece. That's actually how I taught it. One little piece plus the other little piece equals the big piece, because they're all cute little freshmen. So, how easy is that? That's pretty easy, but how many of you got it? It's that simpleness. It's because it's so simple, you think that it must be some magical thing up here. It's not magical. You use your picture, you look at formulas. What is true? So, we couldn't go hopping into the derivative formula yet, but you were getting it from here. And that's what you needed. You needed the formula, then go into taking its derivative. You can never just relate derivatives. You have to start with a formula. Remember when we did the cone problems? The cones had a formula. I think the example I did, R equals 1/4 H. You guys remember that? Am I all by myself in this? My memories are all alone. The cone, we had R, we did a proportion. R over H is equal to 4 over 16, and then we got that R is equal to 1/4 H. Right? That's the formula. We didn't use it because we found how fast is the height of the water changing. But if I asked you how fast is the radius changing after that, I could use that formula because it's a true formula. It's true all the time. It's true from beginning to end. I only put in constant things, so that's a true formula. That's what you got to remember. Anything that's up here is a true statement. As long as I wasn't doing it only at the instant, it's a true statement. I can use it. So if there's parts, part A, part B, part C, you might be able to use stuff you've already started with. Okay? All right. Are we good on this? Okay. So I'll take homework questions at this point. If you have any, and I took down from the other class 17, well 17 was you guys. Aaliyah, are you good, you think? So the proportion comes from the fact that water's flowing at a rate from a conical reservoir. So this is the reservoir, right? But the water started here and starts to go down, and we said we care about the water and not the shape. So your radius is a constant? No. Okay. Your height? No. So no constants there. So I'm going to kind of skip through and get to your formula. Your formula had volume equals 1/3 pi r squared h. Your given information, I think they gave you dV dt, and then they asked you the water level. So they asked you dH dt. Do you see how they didn't mention dr dt? I don't know it. What that means, I don't want the variable. That's where the proportion comes in. So the proportion is the actual physical cone. So if I drew all these triangles separately, they'd all be right triangles with the same proportion. R over H, R over H, R over H. No matter which one. So the proportion I would use is that the radius is 45 and the height is 6. If I want to eliminate R, what should I solve for over there? Okay, that's the piece you needed. All right? That was very similar to the example I did in class. Okay? I think the other class asked me 18. Is 18 a question? Yes, let's go through it. 18 is actually not hard. It's deciphering the picture. So I'm going to go back through the picture a little bit. This is a semicircle. This is a radius of 13. How much is this whole thing here? Middle to here. It's also 13. They're telling us that from here to here is y, and this r confuses everyone. The r is if I looked down at the bowl, you would see a circle. That circle has a different radius r. Are we thumbs up on just understanding what the picture says? Okay. Esma. I'm not there yet. Okay. Are we good with this much? Okay. So, let's see. When we do it, we start with, our picture's already done. I'm hoping you understand there's no constants there except for that 13, but that's not the water anyway. Okay? So there's actually really no constants for us. The question to start off was water level changing. Are we good with that? That's dy dt, that's the water level. Okay. At the instant that it's 8 meters deep. Okay, so are we good there? So now I want to do my givens. Given the 6 meters cubed per minute. Meters cubed tells me that's d. Jasmine, what's meters cubed tell us? Distance, area, volume. Cubed? Volume. You got it. All right, are we adding water or taking it out? Taking it out. Okay. Now that we have that, constants we kind of talked about. There's no actual constants except if you want to call this a constant, that's fine, but it doesn't affect my water. So now the question's already done, formula. Well, they gave it to you, which helps, which is going to get to Esma's question, which was, in here, they ended up with a big R, but they tell you what the R is here. It's the radius of the hemispherical bowl. What was the radius of the hemispherical bowl? 13. 3 times 13 gives me 39 minus y. So this 3r is kind of a little trick to see if you're reading. That's all it was. Just checking if you're reading. Now that I have that, are we good? I have dv dt, but I want to know dy dt. I would simplify personally. That's part A. Are we good on part A? All right, let's talk through each of them. Part B says, what is the radius of the surface when the water is y meters deep? If they do that, that means y is going to be part of your answer. So the surface of the water is here. Do you see a shape that I might be using? Triangle. How much is the triangle's hypotenuse? 13. We know this is r. We don't know this, but we can figure it out. Whole thing, 13. Little piece is y, therefore the other little piece has to be 13 minus y. Then it said, give the radius in terms of, can I make a formula based off of this? This one's obvious. What formula are we using? Definitely Pythagorean. We got a formula. And then part C says, at what rate is the radius changing when we're 8 meters deep again? So 8 meters deep is our y again. We're in the same instance, okay? So everything else in the problem you get to use. Does that explain the problem enough without me doing the whole thing? Travis, you sure? You awake? All right. We good? Ruth, you good? All right. That was 18. Other class also asked 19. 19, part A and B, I thought were fine. Because people thought of it differently. So let's go back up. When they give you the picture, it's always nice too. So it's actually a really easy problem. So let me go grab the picture. Oh. Julie, can you grab the door for me and just grab it from her? Just check if the student's here. Oh, thank you. Let's see, Ruth and Eco is in my other period. There you go. Pass that back to Ruth, please. All right. Were we good on A? Okay, if you set it up, you should be fine on A. Part B now asks you for area of triangle 1/2 base times height. So A and B, we're just ignoring the angle. Does that make sense to everyone? They're not talking about the angle at all. There's no angle to be used. So if you try to use 1/2 base height sine of theta, well, your theta is 90, so. Okay, which is 1, which makes it go away. All right, A and B good? Ty, breathe in and out. Okay, so part C. At what rate is the angle between the ladder and the ground changing? Most people try to use tangent because my example had tangent. It's a right triangle with a theta. What should your mind be thinking? SOHCAHTOA, which has 3 options. SOHCAHTOA. 3 options. If you pick this option, they're both variables that keep changing. So I wouldn't pick that option. Why pick the one with 2 variables? So what I would do, they gave me the basis moving, they gave me dx dt, then I'm going to use x. Because they gave that to me, and I can guarantee I didn't mess it up. Is there a chance that you could have gotten A wrong? Because you had to do anything, there is a chance. Okay, if it's not given to you, that means there is a chance it went wrong. Okay, so I'm going to use what they gave me. So if I'm going to use this side and this side, adjacent side, hypotenuse side, for part C, what am I actually using? Cosine is way easier to use. But I can't put in the x. Okay, make sure you don't put in the x. Good? I believe that should work. I believe that should work. What's cosine's derivative? Theta, don't forget the d theta dt. Do you guys remember how we had to deal with the theta part? We can't find theta, but we can find sine of theta. Sine of theta is opposite over hypotenuse. And I think we're doing this, when is the moment that we're doing it? By the time the base is 12 feet. So this is 12, this is 13, so that has to be 5 at the instant. Now, this is an instant picture. Meaning, don't you dare put a number in for x. Okay? You can't do it till you take the derivative. Did I explain all your questions from the homework last night? Not in my classroom. Okay? Good? All right. So, at lunch, if you still feel like you're not comfortable with it, you're welcome to come and see me talk through. I'm going to give you a quick exit card. You won't finish it because I needed actually 10 minutes to do it. When the bell rings, you're welcome to leave with it. What I ask for you to do is for homework, use more time if you don't feel like you're done in here, and then check it online with a different colored pen, completely different. I'm not grading it. I'm just looking to see how much you know and don't know. So please don't look at other people's answers. If you don't know it and you see that that person's answer is sitting right there, don't write it down. Just leave it blank and change the color and write it in later. Ty. No. But good try. But good try. All right, so work on your own. No talking through it. Try and see what you can do. You don't have to, like, clear your desk or anything crazy like that. It's not a quiz. It's your own honesty. What I will say, though, part 3, or number 3, please understand you're not optimizing all the way. You're just giving me the formula. The formula you're going to optimize. Yes, hon? At 11:30? Okay. That's, I think, now. So, Ruth, before you look at the key, can you do this? And then, okay? Thank you. Ruth was extra awake today.